Hello everyone. So let's now solve question number 2. Match the sets of vector in column A with their properties of linear dependence or independence in column B and the dimension of vector spaces in column C spanned by the sets. So let's look at each set one by one. We have set S1 as, so this is from the option A from here. 0, 1, 1, 1 and 1, 0, 1. So we have 4 vectors in R3. So clearly they are linearly dependent. Now, if we want to find the dimension of this set, then what we can do is we can put each vector column wise and we got this matrix. We will try to row reduce this matrix and the number of pivot elements will give us the dimension of the spanning set spanned by these vectors. So one can clearly say that this matrix is already in REF form and the number of pivot elements are 1, 2 and 3. So the dimension of spanning set of S1 is 3. So now let's look at B. Consider this as set S2 minus 1 minus 1 2 0 minus 2 0 0. So again we will put them vectors column wise. Now this time instead of doing finding the REF or RREF form, we will first try to check whether the vectors are linearly independent or dependent. So as we have 3 vectors in R3, the simplest way to check whether the vectors are linearly independent or dependent in these cases is just find the determinant of this matrix. So I will be finding the determinant along this row expansion. So what we will get is so as the determinant is -4, that is non-zero, so that means these vectors are linearly independent and 3 vectors in R3 that are linearly independent, so the dimension of the spanning set of S2 would be 3. As 3 vectors in R3, those are linearly independent, form the basis for R3. So that's why the dimension is 3. Now let's look at C option. Let's call this as S3. One minus 1, 2, minus 1, 1, minus 2, 2, minus 2, 4. Now, if we try observing the element of this set, we can say that if we consider this as our vector v1, this is our vector v2, this is our vector v3, then v1 is equal to negative v2 and v3 is equal to 2 times v1. If we try, so 1 minus 1, 2 is equal to negative 1 times minus 1, 1 minus 2 and v3 that is 2, 2 minus that is equal to 2 times 1 minus 1, 2. So that means S3, the spanning set for S3 would be it's not necessary that we have to choose this vector. We could have chosen this vector or this vector also. But the point is that S3 would be spanned by only one of these vectors. So the dimension would be 1. last option. So let's name it as S4. So again, we will use our matrix method. If we first try to calculate the determinant of this matrix, we will find that the determinant is equal to 0. This means the set is linearly dependent. So now let's try reducing this matrix. If we do row operation on third row, that is R3 minus R1, then we will get this matrix. On third row, R3 plus R2. Okay, so here it is minus 1, so we got 0. So the number of pivot elements will decide the dimension for the spanning set of these vector. So there are two pivot elements here, 1 and 2. So the dimension of the spanning set of set S4 is 2. Is equal to 2. So that is our answer. Thank you.